On December 7, 1941, when the first Japanese fighters appeared over Pearl Harbor, American pilots couldn't believe their eyes. Those planes shouldn't have existed. According to all military intelligence manuals, Japan was incapable of producing aircraft that rivaled Western technology. Yet there they were, sleek, deadly, and completely superior to anything the United States possessed in the Pacific. The Mitsubishi A6M Zero was not just a warplane. It was a revolution that rewrote the rules of naval aerial combat and forced the world to recognize it had gravely underestimated Japanese engineering. But behind its initial supremacy lay a fatal vulnerability that, once discovered, would transform the most feared fighter of the Pacific into a relatively easy target. This is the story of how the pursuit of aerodynamic perfection created both the greatest advantage and the greatest weakness of Japanese naval aviation. A lesson in how, in war, there is no perfect weapon, only compromises that can determine the difference between victory and defeat. The Zero project was born out of desperate necessity. In 1937, the Imperial Japanese Navy faced a seemingly impossible dilemma. It needed a fighter that could operate from aircraft carriers, but also be capable of engaging land-based fighters in aerial combat. Until then, this combination was considered technically impossible. Naval fighters were traditionally heavier and less agile than their land-based counterparts due to the structural reinforcements required for violent carrier landings. But Chief Engineer Jiro Horikoshi had a different vision. He believed he could create a naval fighter that would not only rival land-based fighters, but surpass them. Horikoshi's solution was radical: eliminate weight where no one dared. While other designers added armor and protective systems, he removed them almost completely. The Zero had no armor for the pilot, no self-sealing fuel tanks, or armored glass. Every component was analyzed, and if it wasn't absolutely essential for flight and combat, it was discarded. The result was a fighter that weighed only about 3,700 pounds empty, almost 1,000 pounds lighter than the American Grumman F-4F Wildcat. This weight difference translated into extraordinary agility and an operational range that would baffle American strategists for months. When the Zero made its first flight in April 1939, the results exceeded even Horikoshi's most optimistic expectations. The fighter could reach 331 mph at altitude, climb to almost 20,000 feet in less than 8 minutes, and had an impressive operational range of 1,130 miles, more than double that of any existing naval fighter. But it was its maneuverability characteristics that truly impressed. The Zero could execute tight turns that no Western fighter could match. Its initial climb rate was superior to most land-based interceptors, and its ability to maintain energy in maneuvering combat was simply unparalleled. The first combat test came during the Second Sino-Japanese War, where the Zero faced Chinese fighters and American volunteers from the Flying Tigers group. The results were devastating for the Allies. In September 1940, 13 Zeros engaged 27 Chinese I-15 and I-16 fighters, shooting down all 27 without losing a single aircraft. Claire Chennault, commander of the Flying Tigers, sent urgent reports to Washington describing a Japanese fighter of extraordinary capabilities. His warnings were largely ignored. American intelligence simply could not accept that Japan possessed superior aeronautical technology. Pearl Harbor was just the beginning. In the following weeks, the Zero dominated the skies of the Pacific with a superiority that bordered on the absurd. In the Philippines, Zeros destroyed entire squadrons of P-40 Warhawks on the ground and in the air. At Wake Island, 2 Zeros engaged 4 F-4F Wildcats and shot down all 4 without suffering damage. Lieutenant Edward Butch O'Hare, who would later become an American aviation ace, described his first encounter with Zeros. It was like trying to fight ghosts. They appeared out of nowhere, attacked with deadly precision, and disappeared before we could react. The Zero's superiority was not just technical, it was psychological. American pilots developed a syndrome known as Zero-itis, a paralyzing fear of facing the Japanese fighter. Many experienced pilots requested transfers to other theaters of operation, preferring to face the Luftwaffe in Europe than to fly against Zeros in the Pacific. The numbers told the brutal story. In the first 6 months of the war, the Zero maintained a victory ratio of approximately 12-1 against American fighters. It was such complete air supremacy that some American strategists began to question whether the war in the Pacific could be won. Saburo Sakai, the Japanese ace who survived the entire war, described the Zero as an extension of the pilot's own body. He could feel every movement of the air through the controls, every change in speed through the seat. The Zero was not just a machine, Sakai said. It was a deadly dance partner that responded to the slightest touch. This harmony between pilot and machine was the result of a design obsessively focused on the flying experience. The controls were incredibly light and responsive, allowing maneuvers that required minimal pilot strength. In prolonged combat, while American pilots struggled with heavy controls and muscle fatigue, Zero pilots maintained precision and agility. The Zero's armament was another aspect of its balanced design. Two 20mm cannons in the wings provided devastating firepower, while two 7.7mm machine guns in the nose offered precision for long-range shots. This combination allowed for both devastating attacks against bombers and precise duels against fighters. But perhaps the most impressive characteristic of the Zero was its ability to operate far from its bases. While American fighters were limited to missions of a few hundred miles, the Zero could escort bombers on attacks over 1,000 miles away and still have fuel for prolonged aerial combat over the target. The first clue to the Zero's vulnerability came from an unexpected source: a lost Japanese pilot. On June 4, 1942, during the Battle of Midway, Petty Officer Tadayoshi Koga was forced to make an emergency landing on Akutan Island, Alaska. What should have been a beach landing turned out to be a disguised swamp. The Zero flipped over, killing Koga instantly, but leaving the aircraft virtually intact. When American patrols found the plane 5 weeks later, they couldn't believe their luck. For the first time, the United States had a completely functional Zero to study. The plane was secretly transported to Naval Air Station North Island, California, where a team of engineers led by Lieutenant Commander Eddie Sanders began the most important tests of the air war in the Pacific. What they discovered would completely change the course of aerial combat. Beneath the Zero's elegant fuselage, American engineers found the source of both its superiority and its fatal vulnerability. The complete absence of armor meant that any projectile hitting vital areas would cause catastrophic damage. The fuel tanks, without self-sealing protection, turned the Zero into a flying bomb when punctured. The test revealed something even more shocking. The Zero was structurally fragile at high speeds. While it was supreme at low speeds, high-speed dives caused severe vibration in the controls and, in extreme cases, structural failure of the wings. The fighter that dominated in maneuvering combat became vulnerable in high-speed combat. Lieutenant Commander Sanders meticulously documented every weakness. The Zero could not keep up with American fighters in dives above 300 mm. Its ailerons became extremely heavy above 250 mm, severely limiting its roll capability at high speeds. And most importantly, its light structure could not withstand the G-forces of violent high-speed maneuvers. These discoveries were immediately transformed into combat tactics. The famous boom and zoom tactic was born: attack the Zero in a high-speed dive, fire a quick burst, and escape in a climb, completely avoiding maneuvering combat where the Zero was superior. Commander John Jimmy Thatch developed the Thack Weave, a formation where two American fighters flew in an intertwined pattern, protecting each other and forcing the Zeros to face crossfire. These tactics transformed the dynamics of aerial combat in the Pacific practically overnight. The transformation was dramatic and swift. In August 1942, just 2 months after the capture of the Akutan Zero, American pilots began applying the new tactics with devastating results. The F-4F Wildcat, previously considered inferior, began to achieve parity with the Zero when flown correctly. Lieutenant Hamilton McWhorter III described the change. "Before, we saw a Zero and our instinct was to run. After the new tactical manuals, we saw a Zero and knew exactly how to attack it." The introduction of the F-6F Hellcat in 1943 marked the definitive end of the Zero's supremacy. Specifically designed to exploit the weaknesses discovered in the captured Zero, the Hellcat was faster, tougher, and maintained an advantage at high speeds. Most importantly, its pilots knew exactly how to fight. Statistics tell the story of the reversal. While in 1942, the Zero maintained a 3-to-1 superiority, by 1944 that ratio had reversed to 6-to-1 in favor of the Americans. The fighter that once dominated the skies of the Pacific became progressively obsolete, a victim of its own design limitations. Jiro Horikoshi, the Zero's creator, watched with growing anguish as his creation transformed from a symbol of superiority into a vulnerable target. In his post-war memoirs, he wrote, "I created the Zero to be the perfect fighter, but I learned that perfection in war is an illusion. Every advantage carries within it the seed of its own defeat. The irony was bitter. The same characteristics that made the Zero supreme in 1941, lightness, agility, range, became its fatal weaknesses when enemies learned to exploit its limitations. The absence of armor, which allowed its extraordinary agility, turned it into a fragile target. Its design, optimized for maneuvering combat, became a disadvantage in a war that evolved into high-speed combat. The last years of the war saw the Zero relegated to kamikaze missions, where its structural weaknesses were irrelevant and its ability to reach distant targets still had value. It was a melancholic end for a fighter that had redefined naval aerial combat. Saburo Sakai, flying Zeros until the end of the war, summed up the tragedy. We kept flying our Zeros, not because they were the best, but because they were all we had. The legacy of the Mitsubishi A6M Zero transcends its victories and defeats. It proved that radical innovation can overcome superior resources, but it also demonstrated that technological advantage is temporary when the enemy learns and adapts. The Zero forced the United States to completely rethink its approach to naval fighter design and aerial combat tactics. More deeply, the Zero's story illustrates a fundamental principle of war. There is no perfect weapon, only compromises. Horikoshi chose agility over protection, range over resilience, elegance over robustness. For 2 years, these choices made the Zero the king of the skies. When the enemy learned to exploit the compromises, the king was dethroned. Today, when we observe a preserved Zero in a museum, we see more than a war relic. We see a testament to human ingenuity and its limitations, to innovation that can change the world, and to adaptation that can neutralize it. The Zero reminds us that in war, as in life, true victory belongs not to the strongest or the most advanced, but to the one who best learns and adapts to the changing battlefield. The Zero's final lesson echoes through the decades. Superiority is a temporary state, and humility in the face of humanity's capacity for adaptation and overcoming is, perhaps, the most enduring wisdom any conflict can teach.